This is Math 7, Section 5.1, Understanding Direct Proportions. To recall some prior knowledge, let's talk about ratios. We want to compare any two numbers, let's say 7 and 8. There are two ways we can compare them. We can either say 7, 8, or 7 over 8. Try this in quick checks 1 and 2. Next, we can say that ratios are equivalent when they are equal to the same thing. For example, 320 and 640 show different numbers. However, they're equivalent because if I multiply them by the same thing, they equal those numbers. So therefore, I know they're equivalent. Same thing if I divide them. By 5 each time, and it's the same thing, I know that they are equivalent. Try this in quick check 3 through 8. Now let's try to find rates. So rates equivalent, we talked about this type of ratio. Rates, we're going to talk about the fraction type of ratio. So if we say in 7 books in 14 days, we could put that into a ratio to say 7 books in 14 days. And we can simplify that. 7 over 14 is the same as 1/2. So they read 1/2 book per day, half of a book per day. And that's how you do that. Try that in quick check 9 through 11. Next, to plot coordinates. You are given a value, and the value is x and y. So if this is our graph, this axis is the x-axis, this is the y-axis. So in x, these are all the values. Here at the center is going to be 0. Same with y. When you go up, the numbers go up. When you go down, the numbers go down. So if I want to find a point here that has x as 2 and y as -1, I would follow along the x-axis to 2, 1, 2. Now follow on the y-axis down to -1, and here's the point. Let's label this point A, and we'll label this point A. If I try another one, B, and it says -3, 3, well, I know on x, I go to -3, 1, 2, 3, and on y, I go to 3, 1, 2, 3, and therefore my point B is here. Try this on quick check 12. Last one we're going to do for recall prior knowledge is percents. And percents we can solve a couple of ways. If we want to solve it with a bar model, we show the whole bar as being 100%. So the question says in art exhibit 80% of the people were adults, the rest were children. So out of this 100%, we have 80% adults, 20% children, because 80 and 20 go together to make 100. So it's that many people total. Now it tells us that there are 600 children. So 20% must be equal to 600 children. So we want to find out how many total people there are. Now we can do this by saying 20% is comparable to 600. So therefore, 1% must be comparable to what? Well, to get from 20 to 1, we divided by 20. So here we must also divide by 20. Therefore, 600 divided by 20 is going to give us 30%. So we know that 1% of this total bar is 30%. Now we want to get this 1% to 100 because that's what we're trying to find. So now we're going to multiply by 100. So here we do the same thing. We're going to multiply by 100. So therefore, 30% times 100 is going to equal 3,000. And that's how many people we now have. Try this on quick check 13 through 14. Now let's get started with direct proportions. So how we are going to identify direct proportion from a table. Okay, so a direct proportion is something that is going to have a constant proportionality rate, which we'll talk about what that is. So for example, if you have strawberries, the weight in X pounds, and you have the cost in Y dollars, and you say for X pounds there's 1, 2, and 3, so this is increasing. Dollars is 2, 4, and 6. We want to find out if it's increasing at the same kind of rate. So notice what happens when you compare them. If we make ratios of each of these, we could say that 1 over 2 is equal to 2 over 4 is equal to 3 over 6. So all these ratios are equal. So this is going to give us a proportion. When they're equal, it gives us a proportion. Now, these are examples of proportions. So let's say that we want to find out how much the cost for 1 pound of strawberries is. Well, we could make a little formula that tells us, all right, the cost per 1 pound is 2, because dollars 2. So $2 times X, because there's X pounds, is going to equal the total cost. And we can see that works when we put 2 times 1. That gives us 2, total cost. 2 times 2, which is X here, equals total cost 4. And notice the total cost is the same thing as saying Y. So we just fill these into our equation. With 3, it's going to be equal to 6. If we had 4 pounds, it would be equal to 8. So we already made a little equation. In this equation, we can find the constant of proportionality. So our equation here says that 2x equals y, because 2x equals y. So we want to find out what is our constant proportionality. Well, the constant proportionality is the thing that is not x or y. So if we divide both sides by x, that's going to give us 2 equals yx. 2 becomes our constant of proportionality. And that's the thing that helps us to compare those two numbers. So that is the constant. Now we're not going to do hands-on activity, but let's try the example. Example 1 says, tell whether the quantities are in direct proportion from a table. Remember, they're going to be in direct proportion if they are equivalent to each other. So if we say G gallons and F fish and we have 4 to 6, 10 to 15, and 20 to 30, well, we can see that 4 over 6 is not the same, 4 to 6 is the same as 15 over 10, is the same as 30 over 20. So they are equivalent ratios. Because if I multiplied this times 2 and that times 2, we get this. If I multiplied this times 5 and that times 5, we also get this. So they are going to be equivalent, which means that they are directly proportional. That was A. Let's try B. So we have T hours, and we have D centimeters, 1 over 9, 2 over 18, and 3 over 21. So we can see that if we multiply that by 2, you get this one. But however, you cannot multiply all of them to equal the same thing. We can't get a direct proportionality from it because the speeds of the snail aren't constant. Like if we multiplied 1 times 3 to get 3, we couldn't multiply 9 times 3 also to get 21. So therefore they are not constant because all of these equal different numbers. For example, this one is going to be equal to 1/9. This one is also 1/9, but this one is equal to 1/7. Therefore, these are equal. These are not equal, so it is not, not equivalent, which means it's not proportional. Try this on guided practice 1 and 2. Now let's do direct proportion from an equation. Before we did it from a table, now we're going to identify it from an equation. So here's our equation. Y over x equals 2. So 2 must be our constant of proportionality. Now let's simplify this so that we don't have a fraction, and we'll multiply both sides by x, which is going to give us, those cancel, y is going to be equal to 2x. Same problem we had before. So we simplified it, and that gives us our direct proportion. In example 2a, we can see that 1/2 y equals 3x. So we have numbers on both sides. We don't want it in that form. We just want numbers on one side. So to solve, we could simply multiply this side by 2, multiply that side by 2, because the 2 and the 2 will cancel, leaving us with y, and these will multiply by each other, so we'll get 6x, and that will be our direct proportion. Trying B, it says y minus 2 equals 5x. Now, we need to simplify this to get our direct proportionality, so we could add 2 to both sides. These cancel, so this becomes y. 5x plus 2 cannot be simplified because the terms are different, therefore this is our answer, and because there's this plus, it is not a direct proportion. This one is a direct proportion because it's in this form. Y equals kx. This is the form for a direct proportion. Try this on guided practice 3 and 4. Okay, moving on, let's recognize this constant proportionality to be a unit rate. So as we discussed before, the unit rate of the strawberries, every $2 you paid for 1 pound. Thus, if that is equal to the total of y dollars, then yes, we multiply this rate times x pounds. So x pounds times this equals y dollars. And this is how we're finding our unit rate. So we can simplify this to an equation to be y is equal to, this is 1, so that goes out, pounds cancel, therefore it's x2, which we could write as 2x, and that's our unit rate. So if we try this in an example, it says identify the constant proportionality. So we're going to do the same thing we did to find this one earlier in the video. So the number of